Imagine you already know two things about a pair of numbers, their HCF and one of the numbers. Now someone asks you to find the LCM. Do you always have to do prime factorization again from the beginning? Not always. There's a beautiful shortcut that connects the two numbers, their HCF and their LCM, like a perfectly balanced scale. Let us first see the idea with small numbers. Take the numbers 6 and 20. From the previous lesson, we know how to find their HCF and LCM. 6 can be written as 2 times 3. 20 can be written as 2 squared times 5. For the HCF, we take only the common prime factor with the smallest power. The common prime is 2, so HCF of 6 and 20 is 2. For the LCM, we take all prime factors with the greatest powers. That gives 2 squared times 3 times 5, which is 60. So LCM of 6 and 20 is 60. Now watch the balance. HCF times LCM equals 2 times 60, which is 120. The product of the two original numbers is 6 times 20, which is also 120. So both sides are equal. This is not a coincidence. For any two positive integers, the product of their HCF and their LCM is equal to the product of the two numbers. In formula form, HCF of A and B times LCM of A and B equals A times B. HCF times LCM balances the two numbers. Now, let us verify this rule using the numbers 26 and 91. First, prime factorize both numbers. 26 equals 2 times 13. 91 equals 7 times 13. For HCF, look for common prime factors. Both numbers have 13, so HCF is 13. For LCM, collect all prime factors needed to build both numbers, 2, 7, and 13. So LCM equals 2 times 7 times 13, which is 182. Now check the product rule. HCF times LCM equals 13 times 182. That gives 2,366. Now multiply the original numbers. 26 times 91 also gives 2,366. Both sides match, so the rule is verified. This formula is only for two positive integers. Do not directly use HCF times LCM equals product for three numbers. That shortcut is special for two numbers. Now let us see why this rule is useful. Suppose you are given this. HCF of 306 and 657 is 9. Find the LCM. Without the shortcut, finding the LCM may take longer because the numbers are large, but the product rule gives us a direct path. Start with the formula. HCF times LCM equals first number times second number. Now substitute what we know. 9 times LCM equals 306 times 657. So LCM equals 306 times 657 divided by 9. First, multiply 306 and 657. That gives 201,042. Now divide by 9. The result is 22,338. So the LCM of 306 and 657 is 22,338. This is the shortcut power of the formula. If you know the HCF, you can find the LCM. If you know the LCM, you can find the HCF. And even if one number is missing, you can find the missing number. Let us try a missing number example. The HCF of two numbers is 13. Their LCM is 182. One number is 26. What is the other number? Use the same product rule. HCF times LCM equals first number times second number. So 13 times 182 equals 26 times the missing number. To find the missing number, divide 13 times 182 by 26. Since 26 equals 2 times 13, the 13 cancels. We get 182 divided by 2, which is 91. So the missing number is 91. HCF must always be a factor of the LCM. For example, we cannot have HCF 15 and LCM 175 because 175 is not exactly divisible by 15. That kind of pair cannot exist. There is one more important case. If two numbers are co-prime, their HCF is 1. Then the formula becomes 1 times LCM equals the product of the two numbers. So for co-prime numbers, the LCM is simply the product. For example, 4 and 9 are co-prime. Their HCF is 1, and their LCM is 36, which is the same as 4 times 9. Now let us bring everything together. Today, you learned the HCF LCM product rule. For any two positive integers, HCF times LCM equals the product of the two numbers. You verified the rule using 26 and 91. Then you learned how to rearrange the formula to find the LCM when the HCF is known, to find the HCF when the LCM is known, and even to find a missing number. Remember the main idea. HCF and LCM are not separate ideas floating alone. For two numbers, they are connected by a perfect product balance.